Today we're going to talk about quadratic functions. In the quadratic function, the form of the equation is y equals x squared. This is the parent function for a quadratic. You can see the general shape of the quadratic function kind of looks like a U. It's called a parabola. If it is a positive quadratic, the U is facing up, it's open upwards. If it is a negative quadratic, then the U is facing downwards. It is open to the negative side. Again, it's called a parabola. When you're looking at a table of values and want to determine if it is quadratic, we first need to look at the differences in the y. Just as we did when we looked at linear equations or exponential functions, we needed to look at the differences in the y. So here in this table, we see that from 5 to 7, we added 2, 7 to 13, we added 6, 13 to 23 was 10, and 23 to 37 was 14, and 37 to 55 are 18. Now notice there's no constant difference here, but there is a constant difference in what is different about the y values. The difference is 4 for each y value. So that tells us it is quadratic. So when you're looking at a table, you first find the first difference. The first difference was the 2, 6, 10, 14, 18. Then the second difference, and notice that the second difference is constant. When the second difference is constant, then you can say you have a quadratic formula. Now let's look at if the graph is increasing or decreasing. So when you're looking at the graph, if it's increasing or decreasing, we look here from this point of the line, or the parabola rather, and you notice that you're going downwards. Because we are going downwards, we are decreasing from negative infinity to 0. Then from this point, which is called our vertex, we are increasing. In this graph, it is from 0 to positive infinity, and that's where we're going up. Now to determine your max and minimum depends on if the graph is positive or negative. If we have a positive graph, then we have a minimum, and if there's a negative graph, it is a maximum. Like this graph above here is a positive graph, and the lowest point here, which is our vertex, is a minimum. It's called a minimum. There is no rate of change as far as quadratic functions are concerned. The symmetry to a vertical line is again at the vertex. So here in this graph, if I put a line through here, through the vertex, you could notice that it is a mirror image of each other. It has symmetry. And finally, the domain and the range of the function. The domain, since it does cover both the negative and positive x values, would be all real numbers. And the range depends on the vertex of the parabola. So at this graph, the vertex is here, so the range would be from 0 to positive infinity. In the graph above, in this negative graph, it would be from 0 to negative infinity. Notice the difference in the way the graph is made. Here is a negative parabola, and here is a positive parabola, or positive quadratic and negative quadratic. We will be going more in depth this year about quadratic formulas and quadratic functions and the type of graph that it makes called the parabola. Hope you enjoyed this video.